Over 500 hours of video are uploaded to YouTube every single minute. I mean, think about that. It would literally take you a lifetime just to watch the content that was uploaded while you were eating your breakfast this morning. So in an explainer like this, we've got to ask, with an ocean of content that incredibly vast, how do we ever find anything to watch? Well, today, we're going to unpack the invisible, mathematically precise forces that are shaping exactly what students are seeing on their screens right now. We normally think of media consumption as a purely active choice. I want to watch this. But the reality? It is far more complex, and it is completely driven by data. So I want you to think about your last binge watch session, or even the last time you saw a student just absolutely glued to their tablet. Ask yourself a serious question. Did you actually pick that show, or did the platform pick it for you? The crazy reality is that the app on your phone probably knows your entertainment tastes better than your closest friends do. We sit down feeling like we have the entire world of media right at our fingertips. But those options placed right in front of our eyes? Yeah, they are definitely not there by accident. They are intricately calculated to capture and hold our attention.
Today, we are popping the hood of the algorithm to look at the hidden mechanics behind the screen. We're exploring the core premise that student media entertainment is now fundamentally driven by highly accurate automated recommendations. It's not just about broadcasting a show anymore, it's about predicting with staggering accuracy exactly what a specific student wants to see next, honestly, often before they even know it themselves.
Okay, let's dive into our roadmap for this explainer. We'll start by looking at student media entertainment, then decode AI curation, break down YouTube and Netflix specifically, and finally wrap up with algorithmic learning in action.
Let's kick things off with Section 1, Student Media Entertainment. Let's look at the everyday reality of a modern student's media diet.
For students today, their daily digital routine is basically a seamless, endless scrolling experience. They open an app, and instantly, out of millions of possible videos or shows, the platform surfaces maybe 3 or 4 options that just perfectly hit their current mood. And that sudden, uncanny accuracy? It's not magic, guys. It's designed specifically to combat decision fatigue. These algorithms intentionally bypass the frontal lobe's active decision-making process by just placing the absolute perfect, frictionless option right under their thumb. Which brings us to Section 2, Decoding AI Curation. Let's actually define what's going on here. So, by definition, AI curation is the automated process where platforms use artificial intelligence to sort, select, and present specific media recommendations. It's helpful to think of it like a tireless, invisible, digital librarian. But listen, this isn't your friendly neighborhood librarian organizing paperbacks by genre. This system is building a massive, hyperdimensional matrix of user preferences. It's analyzing temporal data, like what device is a student using? Is it 3 p.m. or 11 p.m.? What are their historical completion rates? All to instantly predict what they crave in that exact micro-moment.
This idea of an invisible librarian tracking a student's every move to guess their next favorite book, it goes way beyond simply logging what someone clicks. The algorithm is obsessed with micro-interactions. Did a student hover over a thumbnail for, say, 1.5 seconds without clicking? Did they skip the intro? Or maybe they rewinded a very specific 10-second action sequence. Every single tiny hesitation or impulsive tap feeds the algorithm, and it refines their behavioral profile in real time.
Let's see how this works in the wild. Section 3. YouTube recommendations explained.
We have all heard of falling down the YouTube rabbit hole, right? But why does the algorithm actually work this way? Well, YouTube's business model relies on ad-supported revenue, which means their ultimate metric is prolonged session time. Keep you on the app. To pull this off, the algorithm is remarkably skilled at finding adjacent bridges between seemingly unrelated topics to keep the viewer completely hooked. So a student might start by watching a science experiment for a school project, then the algorithm suggests a slightly more entertaining explosion video, and boom, an hour later they're deeply invested in a documentary about the history of fireworks. It just seamlessly bridges educational intent right into pure entertainment.
Now let's contrast that with another massive player. Here is Section 4, the Netflix formula. The Netflix endless scroll operates a bit differently. It relies on creating an environment with absolute zero friction. And one totally fascinating way Netflix achieves this is through personalized thumbnail generation. The AI literally creates dozens of different cover images for the exact same show and serves the specific image most likely to appeal to a user's unique psychological profile. If the algorithm knows a student watches a ton of comedies, they're going to see a thumbnail featuring the comedian in the cast. If they love action, they'll see an explosion from that same movie. The scroll feels endless because the visual interface itself is dynamically personalized just for them.
So while YouTube uses dynamic variety to build this extended rabbit hole, and Netflix uses zero-friction UI and personalized art to drive an endless scroll, their end goal is absolutely identical. They are simply different psychological vehicles powered by the exact same algorithmic engine, AI recommendations. Despite totally different interfaces, both systems are aggressively optimized to capture and maintain student attention.
All right, moving into our final section, algorithmic learning in action. How do these systems actually get so incredibly smart over time?
It breaks down to this loop. The student watches content, the AI learns from that behavior, and then it curates the next recommendation. But this isn't just a simple cycle. It is a highly advanced reinforcement learning model. In machine learning, every single time a student clicks play on a suggested video, it acts as a reward for the algorithm's neural network. It mathematically reinforces that specific pathway. The system isn't just some static database. It's a continuously evolving intelligence that adapts to the shifting preferences of the viewer with every single tap of the screen.
As we wrap up this explainer, I really want to leave you with a final thought to chew on. When a student clicks play, who is really making the choice? Is it the student acting on their own free will, or is it the inevitable result of an algorithm that has studied millions of micro-interactions to ensure that specific video was literally the only logical thing they would click next? Are we consuming the media, or is the media consuming our data to curate our reality? Understanding this invisible curation is the absolute first step to truly navigating our digital world. Thanks so much for joining me today, and keep questioning the mechanics behind your screen.